Hello and good afternoon, geometry students. We are covering another section in Chapter 8, and this is actually the first official section. It's Section 8-1, Day 1, and we're going to be talking about the Pythagorean Theorem today. I'm sure you've heard of that, but we're going to be doing a few more skills with it now that we're in geometry. What I'd like for you to be able to do by the end of this lesson is to identify parts of right triangles and then use the Pythagorean Theorem to calculate missing side lengths. So let's just jump right into it. What is the Pythagorean Theorem? Well, the Pythagorean Theorem is essentially a formula. It is a squared plus b squared is equal to c squared. But what does that mean? All right, so what this means is I'm going to have a triangle, and it has to be a very particular type of triangle. This will not work for just anything. It must be a right triangle. So I'm actually going to go ahead and write that out. Only works for right triangles. That is important. Okay, it only works for right triangles. And essentially what this is saying is if you have two legs of the triangle, we'll call those A and B, if you square them, that is going to equal the length of the longest side, or the hypotenuse, C squared also. So let's identify those parts of a right triangle. A leg is one of the sides, or the sides, of a right triangle forming the 90-degree angle. So this side and this side form this 90-degree angle right there. So A and B are the legs in that right triangle, while the hypotenuse is the longest side of a right triangle. And notice here is my 90-degree angle. It's going to be opposite of the 90-degree angle, and is opposite the 90-degree angle. So we're going to put that into action here. In example 1, it says find the value of x, give your answer in simplest radical form. So we've been talking about simplest radical form in the previous section, so that shouldn't be too crazy for us. And let's just jump right in. I have a right triangle, and I have a side 2, a side 6, and then a side x. X is the hypotenuse. So I'm just going to kind of label A, B, and C. I'll actually write it like this. So now if we were to plug these into our formula, then that'll be more easily distinguished. So A squared is going to be 2 squared plus B squared, which is 6 squared, is equal to X squared. Now it's time for me to start simplifying. I do have to follow order of operations, so I have to square them before I add them. So 2 squared is 4, and 6 squared is 36, and all that's equal to x squared. 4 plus 36 is 40, so I have 40 is equal to x squared. But I don't want to know what x squared is. I want to know what x is. So what I'm going to do is square root both sides, because square rooting is the inverse operation of squaring a number. So that's just going to get me x on the right side. But now I have to take this square root 40 and simplify it. So I'm going to come over here to the side and make my factor tree. That's going to be 4 and 10. And then 2 and 2 and 2 and 5. So the square root of 40 is actually equal to the square root of 2 times 2 times 2 times 5. And remember, when we do this, I take the pair and I pull it up front, or any pairs that I have and pull them up front. So when I pull this 2 out to the front and I leave this 2 times 5 inside of the radical, I'm going to have 2 square root 10 for that final answer. I'm leaving it in this form because it says give your answer in simplest radical form. All right, let's do the next one. I need to identify my side A, my side B, and my side C. Remember, C is always the hypotenuse. So I can go ahead and label 12 as C. And then A and B are kind of interchangeable. I'll go ahead and call 8A and YB. Let's use this now to fill in my values into my formula. So I have 8 squared plus B squared is equal to 12 squared. All right, I need to square my numbers first. So 8 squared is 64, B squared is just staying the way it is, and 12 squared is 144. Now I'm trying to solve for that B. Well, I meant Y, but it's okay. I'll substitute it out at the very end. So I'm going to subtract 64 from both sides. And now I have B squared is equal to 80. Okay. I now need to square root both sides to isolate the B the rest of the way. I do have to come over and work out this square root 80 to the side, though, in order to put it in simplest radical form. So 80 is going to break down into 8 and 10, and then that's 2 and 4 and 2 and 5, and that's 2 and 2. So this is 2, 2, 2, 2, and 5. So I have B is equal to the square root of 2 times 2 times 2 times 2 times 5. This pair and this pair are both going to the front, and when they leave, they become 1. So I have B is equal to 2 times 2 square root 5, or I'm going to replace this B with this Y because I said that they're the same. Y is equal to 4 square root 5. And there we go. One more example. Don't let the fact that I have an X in 2 places throw you off. It's okay. I'm going to say this 4 is A, this whole thing is B, and this guy is C. Let's write that out. I have 4 squared plus X minus 2 squared is equal to X squared. A squared plus B squared is equal to C squared. That's how I got that. Now I want to square all of my terms. Please keep in mind this is a binomial, so we're going to have to FOIL. If you need to go over to the side to FOIL, then you can. So 4 squared is 16, and then I'm going to say plus, and I'm going to go ahead and write X minus 2 out next to itself, just so you can see that. Now I'm going to FOIL. So first, outer, inner, and last. So I have 16 plus X squared minus 2X plus 4 is equal to X squared. This term I got taking X times X. Negative 2X, I have X times negative 2. Negative 2X again, I have negative 2 times X, and then negative 2 times negative 2 gets me my positive 4. Let's simplify that down a little bit. So that gets me 16 plus X squared minus 4X plus 4 equals X squared. I should have combined these guys, but I didn't. So now I have X squared minus 4X plus 20 is equal to X squared. Alrighty. Let's subtract X squared from both sides because we're trying to get those together. but they cancel. So now I have negative 4x plus 20 is equal to 0. So this is just 2 more steps, and then we have the x isolated. I'm going to subtract 20 from both sides. So that gets me negative 4x equals negative 20. In short, if you divide by negative 4 on both sides, x is going to equal positive 5. Alrighty, let's look at some more examples. What happens when we have a beautiful triangle? In other words, no decimals or no fractions. This is something called a Pythagorean triple. And this is basically when the sides of a right triangle are all whole numbers. When the sides of a right, that's important, we're working with right triangles, are all whole numbers. That is no fractions, no decimals, none of that stuff. So here it says find the missing side length and then determine if the side lengths form a Pythagorean triple. Alrighty, let's do that. To find the missing side length, I'm still going to use a squared plus b squared is equal to c squared. So let's label these. I'm going to call this one a, 14b, and then this missing side is c because it is the hypotenuse. Remember, hypotenuse is opposite the 90-degree angle and the longest side. So this is 14 squared plus 48 squared is equal to c squared. When I reduce that, I get 196. 14 times 14 is 196, plus 48 times 48, you need to grab a calculator for that. I believe it is 2,304 is equal to c squared. Okay, now add them up. When I add them up, I am going to get 2,500. So 2,500 is equal to c squared. Now I want to square root both sides. And when I square root both sides, I end up getting 50. And I would just put that into my calculator to check. And the square root of 2,500 is 50. So 50 is equal to c. So I know my missing side length. And what I want you to notice is this. I have 48, which is a whole number, 14, which is a whole number, and 50, which is a whole number. Because none of them have fractions, we can say, yes, this is a Pythagorean triple. So yes, it is a Pythagorean triple. Let's do that same process using Pythagorean theorem to see if this triangle will also have a Pythagorean triple. So I've got A, B, and C. This time the triangle's in a different orientation, but that's okay. The long side is still opposite the 90-degree angle. So I have A squared plus 4 squared is equal to 12 squared. I need to square my numbers first to follow order of operations. And then subtract 16 from both sides. And I'm at a squared is equal to 128. Okay. To isolate the a the rest of the way, because I don't want a squared, I'm going to square root both sides. 128 is not going to give me a perfect number, so I'm going to rationalize it or simplify it, I mean. So let's do that real fast. So I've got 128. That breaks down into 2 times 64. The reason I did 2 is because I just noticed this was an even number, so I just got 2 and 64. 64 breaks down into 8 and 8. 8 breaks down into 4 and 2, 4 and 2. Okay. So now my little leaves are going to be, or my new radical is going to say, a is equal to the square root of 2 times 2 times 2 times 2 times 2 times 2 times 2. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Let's pull all of our pairs out. A is going to equal 8 square root 2. Because this is not a perfect number, meaning it's not a whole number, I am going to say no, not a Pythagorean triple. Alrighty, we just have one more example for today, and then we will be done with this first day of the Pythagorean Theorem. Here it says Jocelyn wants to quilt a pinwheel pattern like seen below. She knows she wants the diagonal segments of each individual piece of fabric to be 6 inches long, and she knows that she wants the other 2 sides to be equal in length. How long should the legs of the triangles of fabric be if Jocelyn keeps her quilt pattern as planned? Write your answer as a radical and as a decimal. So the ink is a little bit tough to see. So I'm going to do my best to make this obvious for you. Let's just focus in on one of these triangles. And we're saying that all of these triangles are going to be congruent to each other. They're all the same size. And I know that this guy right here is going to be a 90-degree angle. And it says she wants the diagonal segments of each individual piece to be 6 inches long. So that means from here to here is going to be 6 inches. I'm going to pull that triangle out just so we can see that. So we've got this guy. From here to here is 6. And then it says she wants the other 2 sides to be equal in length. So I don't know what this length is yet, and I don't know what this length is yet. That's what I'm going to try to figure out. But I do know that they're the same. Because they are the same, I am allowed to call them the same variable. So I'm going to call them both x. Now that I have a right triangle set up, I can use the Pythagorean theorem. So a squared plus b squared is equal to c squared. And if I need to label all of these, then I can. So if I plug in a squared, that's going to be x squared. Plus x squared is equal to 6 squared. Okay, on the left, x squared plus x squared is 2x squared. And on the right, I get 36. Now I'm solving for x. So I'm going to divide by 2 on both sides. And that gets me x squared is equal to 18. I want to square root both sides. And I get x is equal to what? I need to break that 18 down. So that's 9 times 2 and then 3 times 3. So that radical 18 breaks down into 3 times 3 times 2. But as we've been learning, when you have a pair inside of a radical, you pull it to the front. So this becomes x is equal to 3 square root 2. That's part of my answer. It also said to write it as a decimal. I don't have my calculator with me. Give me just a second. Okay, we need to write that as a decimal, so I am going to take the square root of 2, multiply it by 3, and I get x is about 4.24. Alrighty, there we have it for our first day of Pythagorean Theorem notes. I hope you have a great night.